We talked already before about the difference of squares formula. And so the difference of squares formula when we are factoring looks like a squared minus b squared. It has to be minus because it's a difference of squares, not a sum of squares. And that is always going to factor following the pattern of a plus b, a minus b. We did this way when we were multiplying polynomials to start. And we saw that anytime you multiply a sum times a difference, you end up with that difference of squares pattern. Well, we've also seen that you can factor a difference of squares without having to use that formula. For example, if I had x squared minus 9x, well, that's like saying there's a 0x in there in the middle. So if I wanted to set up my diamond and factor it that way, I could. I would get negative 9 on the top, 0 on the bottom, and then 3 and negative 3. And then you could kind of go from there. Well, we're going to look at two special formulas today where the formulas are the only way to factor these expressions. There's not a way to do it without having these formulas at hand. So these are two formulas that I'm going to ask you to have memorized. Okay, so perfect cubes. The formulas that we're going to look at are the sum and the difference of cubes. So with perfect squares, you can only do a difference. But with perfect cubes, you can do a sum or a difference. It doesn't matter. So the first thing you have to know is you have to be able to recognize perfect cubes. So perfect cubes are going to be numbers that are the result of raising a number to the third power. And you should be able to recognize the first 10, I would say, at the very least, and know what base they come from. So the perfect cubes are the numbers that are down there in orange. And the way we get those is we take 1, and 1 to the third power is 1, 2 to the third power is 8, 3 to the third power is 27, and so on. So 1, 8, 27, 64, 125, and on and on and on. Those are your first 10 perfect cubes. So you want those numbers, you need to know them well enough that they kind of jump off the page at you when you see them, that they are perfect cubes. So these are the formulas for factoring the sum and difference of cubes. Now, as far as the pattern of the variables, that is something that you're just going to have to memorize. So I just remember it as a squared, b squared. That's just how I say it to myself over and over again. A squared, b squared. Because that variable pattern is the same for both of these. It's the signs that switch depending on whether it's a sum of cubes or a difference of cubes. And the way that you can remember how to put your signs is using the acronym SOAP. So what that means is same sign is for S, opposite sign is for O, and then always positive is the A and the P. Okay, so again, same sign, opposite sign, always positive. So that's what you want to remember. So if you look at what we have here, the first formula is a sum of two cubes, something cubed plus something cubed. And this is starting with a plus. So if we look at our acronym SOAP, the first sign should be the same. So since we started with a plus, we also have a plus. And then the second sign is opposite. So the opposite of plus would be minus. And then the last sign is always positive. So if you know your variable pattern, a squared, b squared, and you know SOAP, you can figure out the signs. It's going to work the exact same way down here. This is a minus, so this is a minus. And then that's going to be same, opposite, always positive. Okay? It's going to take you a minute to get these memorized. Make some flashcards and quiz yourself over and over again until you have the process down. So let's look at some problems where we would actually use that formula so you can see kind of how it works. So here's two examples that we want to try to factor. w to the third plus 64. So my first clue here is that this is a w to the third. I know right away that I'm cubing w because it says so. So that means I want to check this second guy to see if it was something to the third power. And 64 was one of our perfect cubes on the list. 4 to the third is how we can get 64. So this would be 4. That means that when we set up our formula, wherever there's A's, we're going to put W's, and wherever there's B's, we're going to put 4's. We're not going to worry about positives or negatives or anything because using that SOAP, the formula is going to put the signs where they need to be anyway, so you don't have to worry about positives or negatives at all. So, again, here's how I set up my formula. I know I have a short factor and a long factor, and like I said, I know my variable pattern. A, B, A squared, AB, B squared. And now I go through with SOAP. I started with plus. So same sign, opposite sign, always positive. That's going to be the formula that I use. And so from there, we're just going to take W and 4 and replace it where all the A's and B's are. So I get W plus 4, A plus B, times W squared minus 4 times W, which is 4W. Don't write W4, that's just kind of like bad grammar. Plus B squared, so that's 4 squared, so we get 16. And that is the factored form of this expression. Again, there's no way to come up with that factorization other than using the formula. That is something that you just have to know. Okay? Alrighty. Number 2, again, I notice I have a p to the third and a q to the third, so that's kind of my clue that I want to be checking for perfect cubes. And again, looking back at the list of perfect cubes I gave you, 3 to the third is 27, and 10 to the third is 1,000. So we do have perfect cubes. So that means that this is, the thing that I'm cubing is 3p, that's going to be my A. And the thing I'm cubing here is 10q. That's going to be my B. Okay? Once again, we're going to ignore the minus completely because our formula is going to take care of that for us. So following the factor pattern one more time. Small factor, long factor, A, B, A squared, AB, B squared. And now we go through, you can probably hear my dogs barking, sorry. Now we go through and use the sign. So same sign, minus, opposite sign, plus, always positive, plus. And we'll just put these things in now. Now here you have to be a little bit more careful when you substitute because it's not just a single number. So this first one is not so bad. 3p is A, minus 10q is B. Now when we get to here, 3p squared, that means 3p times 3p. So I get 9 when I square the 3's and p squared when I square p. Now if I do 3p times 10q, and this is plus, 3 times 10 is 30, and then p times q is just pq. And then lastly, plus 10q squared, so 10 squared is 100, and q squared is q squared. So there are the factors. Alrighty. So there are 2 examples coming up. Go ahead and put the video on pause and see if you can work those out yourself. These are the ones that I would like for you to try. So go ahead and pause it now because I'm going to start working them out. So for number 3, hopefully you notice that this is 4y being cubed, and this is 1 being cubed. So when you plug into the formula, you should get A, B, A squared, so that's 16y squared, AB, so that's 4y, because it's just times 1, and then B squared, which is 1 squared, which is 1. And now we SOAP it, same, opposite, always positive. Ta-da! Looking at number 4, this is n that's being cubed, and this is 7r. that's being cubed. So we can set it up a, b, a squared, ab, 7n r, and then b squared will be 49r squared. Same sign, opposite sign, always positive. So there are the factors. That is how you factor the sum and the difference of cubes.